In this video, I will discuss about the classifications of organic compounds. There are over 20 million organic compounds currently known. Most organic compounds are classified based on their specific groups and the bonding of atoms that render their general properties. So these specific groups are known as functional groups. A functional group is an atom or a group of atoms with characteristic chemical and physical properties. So, a functional group determines a molecule shape, properties, and the type of reaction it undergoes. A functional group contains heteroatom, a multiple bond, or sometimes both a heteroatom and a multiple bond. So, a functional group behaves the same whether it is bonded to a carbon backbone having as few as 2 or as many as 20 carbons. So, we have here the most common functional groups. We have the hydrocarbons, halogen-containing compounds, oxygen-containing compounds, and the nitrogen-containing compounds. But in this video, I will only discuss hydrocarbons. So hydrocarbons are compounds that contain only carbon and hydrogen atoms. So they may be described as saturated and unsaturated. When we say saturated hydrocarbons, these are hydrocarbons in which all carbon and carbon bonds are only single bonds, while unsaturated hydrocarbons contain one or more carbon-carbon multiple bonds. So, pwedeng double bonds, pwedeng triple bonds, or pwedeng combination of the two. So, we have here the types of hydrocarbons. So, we have the alkanes, alkenes, alkynes, cycloalkenes, and the aromatic hydrocarbons. First, let us take alkanes. So, alkanes are saturated hydrocarbons with the general formula C sub n H sub 2n plus 2. So, n is the number of carbon atoms. For example, an alkanes with 5 carbon atoms has the molecular formula of, so C, let us replace N with 5. So that is C sub 5, H sub 2 times 5 plus 2. Therefore, an alkane with 5 carbon atoms has a molecular formula of C sub 5 I should say, H sub 12. So that is the general formula of an alkane. So an alkane can exist as straight chain or the branch alkanes. So let us discuss about the straight chain alkanes. So straight chain alkanes are named according to the number of carbon atoms they contain. So let us try to look at the table which shows the first 10 alkanes. So we have the number of carbon atoms, the prefix used, and its corresponding name. So if an alkane with 1 carbon atom, the prefix to be used is met. Therefore, its name will be methane. Then followed by 2 carbon atoms which is ethane, then 3 propane, 4 butane, 5 pentane, 6 hexane, 7 heptane, and so on. So with the exception of the first 4 compounds which are the methane, ethane, propane, and butane whose names have historical origins. So the alkanes have Greek prefixes to reflect the number of the carbon atoms. So we have the prefixes pent, which means 5, hex, which means 6, 7, hep, 8, oc, 9, non, 10, dec. So the suffix ane identifies the molecule as an alkane. So alkanes are commonly used as fuels. So we have methane, ethane, propane, and butane are all components of natural gas. So propane and butane are the major gases in liquefied petroleum gas, which is known as the LPG. So on the other hand, we have the branch alkanes. So branch alkanes are carbon atoms bonded to 3 or 4 other carbon atoms. So that will result with branch alkanes. So each carbon in a molecule is described as primary, secondary, tertiary, or quaternary. So let us try to look at this image. So when we say primary, it is primary if it is bonded to only one carbon atom. So as we can see from the image, yung primary natin, it is only bonded with one carbon atom, or it is only connected with one carbon atom. So the carbon atom in CH3 is only bonded with one carbon atom in CH2. So it is secondary if it is bonded to two carbon atoms. So as we can see, CH2 is bonded to two carbon atoms. So one from the carbon on CH3 to its left, and another one is the carbon on CH to its right. So that is secondary. Then, it is tertiary if it is bonded to three carbon atoms. So as we can see from the example, so the CH is bonded, or the carbon in CH is bonded to three other carbon atoms. So one to its left, which is CH2, then one to its right, which is CH2, and one above it, which is CH3. And lastly, it is quaternary if it is bonded to four carbon atoms. So as we can see, carbon is bonded to its left, to its right, above it, and below it. So that is branch alkanes. So another hydrocarbons is the alkenes. So alkenes are double bonds in structure. So alkenes are also unsaturated hydrocarbons with general formula C sub 2 H sub 2 times N. So again, N is the number of carbon atoms. For example, if we have an alkene with 5 carbon atoms, so that is C sub 5 H sub 2 times 5. So that will give us C sub 5 H sub 10. So straight chain alkenes use the same prefixes as the alkanes, but end in ene. So just like on the alkanes, we also use the same prefixes, but the only difference is their ending. So kung sa alkane, it will end in ane. Sa alkenes, it will end in ene. Example, we have ethene. So ethene has two carbon atoms. So that is C sub 2, then H sub 2 times 2, which is 4. So therefore, we have the molecular formula of C sub 2H sub 4. Another is the pentene. So pentene has 5 carbon atoms. So replace N with 5. So that is C sub 5 H sub 2 times 5, which will give us 10. So, ethene is responsible for the ripening of fruits, while pentene is an organic solvent. So, that is alkenes. Next will be alkynes. So, alkynes are unsaturated hydrocarbons having the formula C sub n H sub 2 times n minus 2. For example, if we have an alkyne with 5 carbon atoms, so let us replace n with 5. So that is C sub 5 H sub 2 times 5 minus 2, which is 8. Therefore, an alkyne with 5 carbon atoms has the molecular formula C sub 5 H sub 8. So, alkynes contain triple bonds in their structure. So, straight-chain alkynes also use Greek prefixes but a suffix of y and e. Just like on alkanes and alkenes, they use the same prefixes, but the only difference is their ending. So on alkane, it ends with A and E. Alkenes ends with E and E. And alkynes ends with Y and E. For example, we have ethylene. So ethylene has 2 carbon atoms. So that is C sub 2 H sub 2 times 2 minus 2. That is 4 minus 2, which will give us 2 hydrogen atoms. Therefore, ethene has a molecular formula of C sub 2H sub 2. So, the simplest and smallest alkyne is ethyne, more commonly known as acetylene. And another example is pentyne. So, pentyne has 5 carbon atoms. So, that is C sub 5 H sub 2 times 5 minus 2, which will give us 8. So, that is C sub 5 H sub 8. And next is the cycloalkenes. Cycloalkenes are saturated hydrocarbons in which carbon atoms are connected in a cyclic arrangement. So they are usually represented as polygons. So as we can see from the image, we have the cyclopropane, so that is represented by a triangle, cyclobutane, which is represented as a quadrilateral, and a cyclopentane, which is represented as pentagon. So the corner of these polygons corresponds to a carbon atom attached with 2 hydrogen atoms. So on our cyclopropane, we have 3 carbon atoms, wherein each carbon atom is attached with 2 hydrogen atoms. Same is true with cyclobutane. We have 4 carbon atoms, and each carbon atoms has 2, or it is connected with 2 hydrogen atoms. So cycloalkanes follow the general formula C sub n H sub 2 times n. So that is just the same with the alkenes. So for example, if a cycloalkane has 5 carbon atoms, therefore its molecular formula will be C sub 5 H sub 2 times 5, which is 10. So that is C sub 5 H sub 10. And lastly, we have the aromatic hydrocarbons, or the arenes. So these are compounds that contain a benzene ring in their structure. So a benzene is a 6-carbon ring which has a molecular formula of C sub 6 H sub 6. So that is the simplest arene. So this is what we call the benzene ring. The term aromatic is derived from a characteristically strong and pungent smell emitted by most arenes. So, among these substances are the naphthalene, commonly known as the mothballs, and toluene. So, yung naphthalene natin is used as an insect repellent, while the toluene is an ingredient of petroleum products such as paints, or sorry, it is an ingredient of petroleum products, paints, and adhesives. So, those are the hydrocarbons. Thank you for watching, and I hope you have learned something.